yesterday was measures of center. In other words, we looked at mean, median, and mode. How do you find the middle of a set of data? Today, we are talking about dispersion is like how spread out are your points. Are all of them very similar, or do we have some high and some low values? We're actually just going to jump in with an example to start. So this one says, to order food at a McDonald's restaurant, one must choose from multiple lines, while at Wendy's restaurant, one enters a single line. The following data give the wait times for a simple random sample of 30 customers at each restaurant during the lunch hour. So we want to give the mean waiting time for each of these. Is this a sample or a population? Sample. So mean, we use what variable?
X bar.
So we want to find X bar for each of them, and then we're going to compare. So what I want you to do is take a minute, do these on your calculator. What I would do, I would probably put like all the McDonald's in L1 and all the Wendy's in L2, and then we can kind of get both at the same time to get our mean. So we could do one at a time, but we also have two sets of data we just entered at the same time. So if you go to stat, calculate, if you want to do both at once, you can go to your two variable statistics. Now it should be my X I have set for L1 and my Y for L2. Does everyone have that? Okay, so then we can just go down to calculate. Alright, so the X bar is the mean of my first list, because I put these in my L1. So I get 1.3893. The mean of my second is the Y bar, because I had my Y to the second list. So that's 1.3907. Alright, if you did not get those numbers, all that means is you mistyped a point. So it is very tedious, and those were written really closely together, so that can definitely happen easily here. It's really not a big deal in terms of our example, going back and trying to find the one you typed in wrong. But I just wanted to talk about the process, how you can enter both sets and look at your mean from there. If I look at this, this is in minutes. Is there a huge difference between 1.3893 minutes and 1.3907 minutes?
No.
No. So it looks, if I'm just looking at the mean, both restaurants are about the same. I can expect to wait a little over a minute if I'm going to go in. Now if I looked at the histograms, I went ahead and made them for you. Do you have any comments on those and notice anything about those?
McDonald's is very much quicker, it seems.
Okay. McDonald's looks like most of the time you're going to get your food or place your order immediately. But Wendy's probably not within the first half a minute, but between 30 seconds and a minute you place your order. So again, not huge. Both of them, you're more likely to get it right away than later on. What about at Wendy's? What's our maximum time? 4 minutes. What about McDonald's? 5. Is there a difference there?
Yeah.
Okay, so, and you look, with our Wendy's, almost everyone got it in under 3 minutes. But at McDonald's, after the 3-minute mark, we still had quite a few orders that took over 3 minutes. So if we're looking strictly at the mean, they're about the same. When I start looking at this, they might be a little bit different. Looks like McDonald's, if I don't get it right away, I could end up waiting a while. Wendy's, I'm probably not going to get it immediately, but they're more consistent on getting it faster. So this is what's called the spread of the data, when you start looking about how spread out it is. And there's different ways we can measure it. The most basic one you've probably done before, the range. And so range is just the difference between the largest and the smallest value. If you guys have that formula sheet I gave you yesterday, and we are still using this, this is the next one on there. And it just says range is your largest value minus your smallest value. So that's a formula that's given. ask you to find your range. Your highest minus your lowest. Kind of an idea of how spread out it is. If I'm looking at, an outlier, is the range going to be resistant to very high or very low numbers? No. If I throw in somebody that waited 15 minutes, it's going to make my range huge. So kind of like the mean, an extreme value is going to change this quite a bit. Alright, let's kind of switch gears for a second. I want to look at a different example, but do not delete that data out of your list yet. We're going to come back to it in a second. So leave that in there. Let's go back to that example we were using yesterday with our 7 employees at our web company. If I asked you to find the range of this, usually for range we just do capital R. What is our highest?
43.
Minus, what is our lowest?
5.
So our range is
30.
38 minutes. So range, we're just doing a subtraction problem. Now range doesn't really give us a whole lot of information because we don't know, is it just one high value or did we have a lot of high values? So it's kind of like a mode. We can find it, but we're not going to use it a whole lot. A better option is what's called standard deviation. And this is most likely something that you have not done before. So mean, median, mode, range, we've probably seen all those. Standard deviation is new. Okay, if you look at this formula, it looks terrifying, but it's really not that bad. So our population, so just like with mean, we have different variables if we're talking about a sample or a population. Population, that's a Greek letter, it's called sigma. So you can find it by doing each value, so your value, minus the mean, and squaring it. So the purpose of the squaring is to make it positive. And then, do you guys remember what does the sum mean, or I just told you, what's that symbol mean from yesterday?
Summations.
It's a summation. We add them all up. So we basically take each one, subtract the mean, square it, add them all together, divide by the number of points, and we do the square root of that whole thing. Alright, there are a couple different variations of this formula that will be equivalent. When I do it, I'm going to use this first one. So if you look, I think the formula sheet includes both of them. We are going to do the first one. If you're doing it by hand, this is just a little bit easier. Alright, this is something that is a little bit tedious to do by hand. So we are going to walk through one together. And then we're going to talk about how to do it on the calculator. So again, don't delete that data out of our list yet. I'm going to come back in a second and
What
leave
is
that.
F5? Alright, what is F5?
Oh, that's the root. So if I wanted to find the standard deviation for our web company, what we are going to do is make a table to do this. So I am going to list each x, and I'm going to take my x minus the mean, and then we square that. Because the formula said we had to square them all and then we'll add them together. So I'm going to organize it like this. So my different times, we had 23, 36, 23, 18, 5, 26, and 43. You know what I look back in their notes from yesterday? What was our mean when we did this example?
38.
Was it the first time? I was thinking it was like
Oh.
1.
The first time it took capital.
Is it?
This one, 16, 53.
Alright, so yesterday we did this example, and we had a mean of 24.86. Otherwise, how would you find the mean if you had to recalculate it? Add them all up, divide by ours. So we are going to go through and do each one minus the mean. So I'm doing 23 minus 24.86 gives me a negative 1.86. And then I'm just going to go ahead and hit square while it's in my calculator. So then I square that. So next one, 36 minus 24.86. And then we square it. Okay, 23 again. I'm just going to copy down the values from the last time we had a 23. 18 minus 24.86. And square. Does everyone understand where I'm getting my numbers? Do you guys feel like you could get all those numbers right? So the formula, standard deviation, is the square root of, we said this is the sum of all the x minus the mean squares divided by n. Alright, so we add up this final column. Divide by, what is capital N?
The number of terms, yeah.
The number of terms. So then I put that in my calculator one final time. And I get a standard deviation of 11.356. Alright, so this is time consuming. We are not going to do a lot of these by hand. On your homework, I'm going to ask you to do one problem by hand. We'll probably pick the smallest set of data to do it by hand. Test or quiz, I might ask you to do it by hand once with a small set of data. But if we have a lot of points, it's not necessarily hard, but it's just a lot of calculation and easy to make a mistake. So go back to, I'm actually going to jump on here down to example 5. Back to our McDonald's and Wendy's example. If I want their standard deviation, first of all, were these populations or samples? Samples. So I guess maybe I should mention that first. I think that's our next slide. A sample standard deviation, the formula is slightly different. So notation, sigma is for a population, S is for a sample. If you forget, it's on your formula sheet. It has population and sample. Again, if we're doing it, we are going to use the first version. It's very similar. Your value minus the mean of the sample. So we square all those, add them up. The difference is, in a sample, we divide by n minus 1. And there's a very long explanation with that. It has to do with degrees of freedom, but I'm just not going to get into it right now unless somebody's super curious. You can come talk to me. But this just is the formula. Okay, we'll divide by n minus 1 if it's a sample. If we want to do this one on our calculator, since it's a sample, we are going to look for that S. So if you go back into your stat calculate, let's do our 2 variable statistics. So X is still L1, Y is still L2. You might have to go down a little bit so you can see them both, but notice it gives me standard deviations. Now it gives you both S and sigma. So you have to know, was this a sample where I would use the S, or is this a whole population where I use the sigma? So you have to decide. They're very similar, but there is a slight difference there. So the standard deviation at McDonald's is 1.2649. At Wendy's was 0.7384. Now, as we do more this semester, we will learn a little more about what these standard deviation numbers mean. But right now, what you need to think, the bigger the number, the more spread out your data is. The closer it is to 0, the more similar your data is. So if I'm looking at these numbers, McDonald's has a bigger standard deviation. Why? Right, theirs were more spread out. So this one's larger because the times were more spread out. So if I were trying to make a decision on these restaurants, I might say, well, in terms of mean, they're the same. I could go with either one. But if you look at standard deviation, Wendy's is going to be more consistent at hitting that mean time. Whereas McDonald's, you might get in faster, but it might take you a lot longer. So the smaller the standard deviation, the better here. Is this okay? I wanted to show you the calculation for a sample one by hand, but I picked a very small sample. We're only going to do 3 points. Okay. So if I wanted to take this sample of 3 employees and find my sample standard deviation, and it is a sample because I have 7 employees, I'm only looking at 3. I went backwards. This is example 4. So the formula, if you're looking at your formula sheet, the sum of x minus x bar, which is just your mean, squared, divided by n minus 1. So we need our mean here. How do we find the mean of these? Add them up. So 5 plus 26 plus 36, and divide by 3. Going to find my standard deviation. We will do our value minus the mean, and then we'll square it. 5 minus 22.33. Squared. 26 minus 22.33. So, now the symbol means we add those up. So I would add these three numbers. Divide by n minus 1, which would be
2.
2. We only have 3 points, so 2 minus 1. So I'm doing the square root of that whole thing. And it's more likely, if you're doing one by hand, it's probably going to be a sample, because I'm not going to give you very many points if you have to do it by hand. What does this standard deviation tell us?
The times are way spread out.
It's way spread out. Those are 15.8. You know, our last standard deviation we had like 0 point something. So this is much higher, which means it's much less consistent. We have a wide variety, and we saw that in our original point. Somebody commuted 5 minutes, somebody commuted 36 minutes. It's much more spread out. All right. Questions there? Let's run through variance next. It is actually fairly simple. Variance is just standard deviation squared. So population variance is just your population standard deviation, your sigma squared. Sample variance is your population standard, or your sample standard deviation squared. Again, it's on your formula sheet. Okay, so we don't have to memorize any of this. We don't even have to memorize what letters everything stands for. It's all here in front of us. So if I asked you to find the variance for the statement, let's just do the population variance. So from, which example did we do that on? From example 3.
1, 1, 3, 5, 6, 9.
What did you say? 1 point.
3, 5, 6, 9.
Okay. So we found that standard deviation. So variance, we just square it. Variance, we aren't going to use it a whole lot because standard deviation really gives us what we need. But you might hear this referred to. It's kind of the same as standard deviation. Bigger the number, the more spread out your data is. That's really all it means. All right. Any questions here? You want to stop here for today? So homework-wise, I think I printed it on the last slide. We are not ready to do all of it yet. You can do really probably just the first 4 is all we're really ready for. I would like there's a couple of them that ask for standard deviation, but let's only do one of them by hand, it's time consuming. So let's make problem 14 be the one we do by hand, because it's the smallest data set. And then the others, when it asks for standard deviation, use your calculator. Put it in that L1 and get your data from, or your standard deviation from there. You guys have time?